Hello everyone and welcome to this new review episode where we are going to continue to learn how to build a very mature function from a code that we built from scratch. And this is bringing us to create a very easy code to use with a good simplification to make the input the GPIO input function. And by the end of the lesson today, we will be able to build a code that you see here in the screen, where you have the ability to control the LED status with the some kind of a push button, and you can create both ways, the active low or the normal way. So you can see here that we do have an LED that is already on, and by clicking on the push button it turns off. And we have also the other way around, where when I click on the push button the LED will be turned on, and we can expand this to every one of the push buttons, and you can see that will be a very simple code to use, that we will also use the code from the previous episode, and in the total have a very mature code to manage our program. So if you enjoy and would like to learn how to create this kind of code, just stay tuned and follow with us. Our start point for this tutorial will be the previous tutorial's code. So we are taking the same code, exactly the same code, but we are focusing now on building the input function. So this will be exactly same logic. That will be the exact same logic that we have used for creating the output function, but with the change that we need for the input. So what we are going to take, so those are the function we created last time, and we are going to output set here and add a line here just under the output set. This time, the input from the function will be an integer, and that will be an int, and we are going to set pin input set. Okay, and again, the only input for that function, or for this function, will be just the port pin as usual. And let's create the function. We are going to use exactly the same thing, but so those are the function, the the preparation that we need. So let's bring this one like this, and there's an error somewhere. Let's check. So here pin input set, and let's check what is the error. One function does not return a value. That's clear. And we can put here the return. We can add it later on, but we will need, so we need to have a return. So we put return 0 here just in case, and that should clarify the whole error message that we do have. Okay, so you can see that these two code, the first one is to get the port, the second one is to get the pin, and then is to get the GPIO. So, but what we need to have here, so we also need to set up the GPIO port init. So we need to initialize it just in case. And after that, you see here we do have the pin mode out here. So let's create a new function here, the same one that will generate for me the pin mode in. So we can just copy here, and what we can bring is not out anymore, but we put it in. And here, the code we created previously, we would like to define as an input in this place. So far, we do have a very clear code on how we would like to set up this function. So we just copy here, and we are setting up our port as an input here. So by this, we are setting up our port as an input. So you can see by creating those functions, coding gets much easier, because everything is set up and modular enough so we can use them or reuse them again. So after that, we can compare quickly with this function. So what's happening here is what we need to do. So this is the output setup. So this is where we set up the pin before setting up this one. Let's check. Something is not correct. Yeah, okay, something is missing in this function. And oh no, this is the in one, of course. So what we need is to bring the output function. Okay, this is the output function, and it's missing two sets of code. Interesting enough, so we need to bring the code. Yeah, I think this is missing from our previous code. So auto type here, and the pin output mode is missing here. So what we need to bring, again, I think this is a small mistake of the code, and we bring the code that we wanted from here to here. And we bring it back here to correct our output setup function, where we put our pin as an output, and we remove the C. That's quite a huge mistake from the code. I think that should be corrected later on. And here, this is correct. This is where we put the pin. And this is again where we put, the pin with a small pin letter, and also here the pin. And this is when we set up the pin as an output. Okay, but also it's not 01 that we would like to put here, but actually the output, which is out here. So what we need to copy now, so let's check what's going on, why this is not correct. There's something missing, and probably this is the one missing here. That should correct the thing. Yep. So let's copy this one, exactly copying it. And what we would like to do in the pin output set, we go here, but here we would like to set it as an input. So we don't even need this line, because by setting up to 0, this is what we want to do as an input. But just for sake, we can put here input, like this, the input. Okay, so far this is clear. And we can go back again to our code and see how we did set up our functions. So let's go here and take a look when we wanted to set our PA4 as an input. So we put it our input and then the output type. So we set up the output type as a push-pull, so exactly same. So if we go here, we can copy exactly the same thing like this. And so this is GPIO. But after that, we do have the resetting of, just let's go for this one, and the PDPR. So if we go back here and go to our PDPR, we want it to go to this pull up, pull down, and change it, as you can see here. So we want it to set up as a PD. So let's copy this like this and bring it here to see how we can modify it. So first of all, we remove the A and then resetting the value, and this is by putting here the pin number. And after that, so here again, I need to remove, that's correct. And also I put the pin here. And to avoid having any kind of, we try to give a name for everything, let's go back again and check here. So for the function name that we do have, that we need to put, so we do have this one, no pull up, no pull down, 0, 0, pull up is 0, 1, pull down is 1, 0. So let's start doing this. So no pull up NPP, and then let's go. So define NPP as a 0, and then define another define here as for PU as 1, and define the pull down as a 2. So let's put them at the same level and have a final check. So pull down and 1, 1 is reserved, so we don't need to think about it. And we have seen here so that we put it the 2, so it's a PD, and we go back here, put a PD, so we have a very clear way on how we manage. So this is pin as a PD. Okay, so we do have now the function, and actually this function is also a void because this is not the read function. Yeah, and we don't need a 0 here yet. So this is just the function that will set our pin as an input. Okay, so we do have this function ready. We are now ready to copy it and paste it here. So we can set our pin as an input. Well, we have completed setting up the input function, so the function that set the pin as an input. So now what we are going to do is create the function that will read the status of the pin itself. So we can here hide this function like this, and you guess it. So this function is a pin write, and the new function that we are going to create is this one will get an input as a char, and we are going to call it pin read like this, and that will have only the integer input as a port pin. So this is the pin where we would like to read the state. Okay, so for this function, unfortunately, again, we are repeating a little bit ourselves, and we are going to get all this function, all this little code that we would like to set up. And one day I will show you a way to not repeat it, but it's good to have this one with us each time. So what we are going to read, and we are going to check. So if the GPIO, and the register, so if we go back here, so the input data register here, we are checking the input data register. So if this GPIO EDR, and we put and this is where we check against the pin location. So we put here our pin like this. So if this one is we find the 1. So what we are going to do is put an and between these two one. So here we are going to check only the bit position at the pin number, because this one is only a 16-bit location register. It's a 32, but here only a 16 occupation register. So if this one is equal to 1, we are going to return, you would say 1, but I would say no, I would not be using 1 here, because instead I will be using the 0x, the hexadecimal FF. And why I would be doing this? Because sometimes I would like to read the opposite of what I'm reading. And if I return 1 and I add a tilt, so let me comment it here and explain it. So because if I'm returning 1 and then I try to tilt it, so get the opposite of 1 for the number that we do have, which is a char, which is a 0 FE, like this. So the tilt of 1 is a 0 FE, which is also kind of a logical one, and that's what I don't want. But if I put an FF here, but the 0 hexadecimal FF, the tilt of the hexadecimal FF is if I put, where is the tilt? Here is a 0. So that's why I'm putting this one like this. So let's go again and put else. So if it's not a 1, we are returning a 0. Okay. So this is how we have our read function. So we input just the pin port, like PA1, PA2, whatever the other pin that we do have, and we will have the two conditions where we will have kind of a logical 1 or a logical 0. And this is a function that we will need to have within our code. So I'm also adding this one to our headers so we can export it. Creating the read function gives us really a big opportunity to have a third function that will be very useful from the pin control perspective. And this will be the pin toggle function. So instead of keeping every time checking if the pin is on or off, we can have a kind of a very simple function that will toggle the pin whatever the value. So let's finish our development for the GPIO simple function by creating our toggle function. So here we put a void pin toggle like this. And as usual, we will just need the port pin value. And let's put it like this. Okay. And same as usual, we just copy this. And here, I always enjoying writing sometimes a code that is kind of shorter, but it's quite fun to write. This is a little bit compacted C. So what we are going to do, so pin read. So we are going to read the port pin value. So the port pin like this. And when we add a question mark, it's kind of a function. So if the value here is 0 or 1 or a logical 0 or 1. So if it is 1, so what we need to do, we are going to make port like this. So port pin, or we can just use our function, the pin write here. So if this is, if it's a 1, I would like to turn it off. So pin write, and we use port pin here. And what we need to put here, off. So we turn it off. Else, we put pin write and port pin like this. And we add here as on. So this will be a very simple function that will be playing and checking each time. So this will be toggling the pin without the need of checking each time the value, so we don't repeat ourselves. We got everything ready now to jump for the next step and the final one, which is going and have some practical experience to see how things are working with our new code. Just before jumping there, and not forgetting that, just getting this void toggle pin and putting this function within the header file so we can use it in the future application. Okay, so let's go to the main application program, and we do have this is coming from our previous code. Now we don't need any picture of this, and we are going to get the whole thing from scratch. It will be quite short and easy. And let's delete those line here because we don't also need those 1, 2. So let's bring those 1, 2 out like this. Okay, and quickly just bring this one. I think the D2 is one that I have changed between the two codes. Let's go here. We don't have any output for the D2, and let's see, let's change it to C2, for example. No, C2 is already taken. We can take the PA5. Let's take the PA5 here. A5, as we do not have any D2. Perfect. So let's quickly take a look to our circuit and understand what's going on. So this is our circuit. This is a new circuit that we do have. And what we have here is our microcontroller board. And on one hand, we do have the LED bar that we have used in our previous tutorial. But what we have added now is 5 push buttons that are connected with a 3.3 volt, and each one I'll be clicking on this button. We should have a connection, or one of the LEDs from the LED bar should be turning on. Okay, to do so, it's quite simple using our new code here. So let's quickly, so we set up as in the output, they are ready, but now we need to put the pin input set, and we get the pin list here. We do have the A4, E2, D1, B10, and D0. Hope I would be able to memorize all of them. PA4, then we can copy the whole thing and just, so it will save us a bit of time. Okay, so after A4, that should be E2, and after E2, we do have the D1, and after D1, we do have PB10, and if I still remember D0, yeah, D0. And you can see this is the code that will initiate those pins to be as an input and reading what will be the value of the voltage applied to this pin from a digital perspective. Okay, now we can initiate our while loop like this. Yeah, not like this, but let's close it like this. And what we have to run is a simple pin write, the status of a pin read. And let's go here. So we have a pin write for the PA0, for example, and we would like to read what will be the state of here, the pin read of the PA4. Okay, so that should be enough, and we are going to test initially for this one. So let's save and then build. Zero error, zero warning, looks to be good. Let's bring back now the video of the microcontroller and load our code. Okay, seems everything is good. The PA4 is the pin that is connected to the red push button, and I should have the PA0 connected to the first LED in this bar. So now by clicking on this red push button, we do have the red LED, the blue LED turning on, which is exactly the expected behavior. Then we can expand on this and do the same thing for the rest of the pins. Let's do it quickly. So we do have the PA5, which will be connected to the PE2. Then we do have the PC2, which is connected to the PD1. And you see everything is pre-ready, or the data is already set up. We don't have any magic number. So this one is the PD15 connected with the PB10, and finally the PE6 connected with the PD0. Okay, so this is the last thing that we do have. Let me show you again the picture here. So this is, we are going to write on a certain pin, reading the value of a certain LED, a certain signal. So let's build and bring back the picture, and let's load it. Let's check every push button. So we should see this is a blue, this is a yellow, this is a green, this is another green, and this is an orange. Let's change a little bit just to see how fun it is. And if I take, for example, the PA4, the first one, and I use a tilt here, let me show you the picture. And this is what shows. So if it's the opposite, if the pin is not clicked on, that should be the opposite value. So what I should see is the LED connected with the pin PA4 should be always on, but when I click, it will be off. So let's save, build, bring back the video, and load it. Okay. Okay, interesting. So what I'm having here, pin read, is not working. Okay, so this isn't giving me, yeah, and understand why this is not working, because that's wrong. I should not put the tilt here, but the tilt should be here. And that's a good error. This is a learning error. So my mistake was I was putting the tilt in front of PA4, which was wrong, but I should put it within here. So let me build again, save and build, bring back the video, and I should, as soon as I load the code, have the LED, yeah, on. And when I click on the push button, that LED turned off immediately. So you see now how this is quite convenient and easy to use those LEDs and to use this function to control digital signal. I hope you enjoyed this episode and see you in the next one when we will see a bigger example how we can use this function. Again, thank you so much for following this episode and see you next time. Have a good day. Bye bye.